Good morning, everyone. Welcome to the session 7 from the playlist of friction, and the topic is acceleration of a block on a rough surface. So, here I will be taking a couple of cases. The first case is when the block is lying on a horizontal surface. This is a block which is lying on a horizontal surface, and I have applied an external force F which is horizontal to which is parallel to this horizontal surface, and the coefficient of kinetic friction between the block and the horizontal surface is mu. Coefficient of kinetic friction is mu. First thing. Second thing, the mass of this block is m. M is the mass of the block, mu is the coefficient of kinetic friction between this block and this horizontal surface. This is mu. So, the weight of this block will be acting in the downward direction, which will be equal to mg. The normal reaction acts perpendicular to the surface, which is denoted by n, and this will be equal to mg. So this is the external force F, which is applied in a direction as shown in this figure, and the this force is applied parallel to this horizontal surface, and the coefficient of kinetic friction is mu. The mass of the block is m. Now, in this case, the weight of the body or the block will be acting in the in the downward direction, and the normal reaction will be acting in the upward direction, which will be perpendicular to this horizontal surface. Here, this normal reaction will be equal to the weight of this block, which is equal to m into g. And now, since the block, let us assume that this block starts moving in this direction with an acceleration a. So in this case, the net force on this block will be equal to the force which is applied in this direction minus the frictional force which will be acting in the backward direction. Let us denote this frictional force. I am denoting this by, let us say, Fs. This frictional force is equal to mu into n. Now, since the force is applied in this direction and the body is moving in this direction, and the friction, it opposes the relative motion, therefore the frictional force will be acting in this backward direction, which will be equal to mu n into n, and this mu n is the limiting value of the friction. That is, it is the maximum value of the frictional force which which will be generated when this block moves in this direction as indicated by this arrow. This is the maximum value of the frictional force. So the net force on this block or this object, when it moves under the influence of this external force F, will be equal to F minus Fs, where Fs is the friction force. So this is equal to F minus, now Fs is equal to mu into n, and n is equal to mg. So this is equal to mu mg. Now we know that force is equal to mass into acceleration, and the acceleration which is developed in this body is a. So we can write this equation as m into a, where a is the acceleration produced in this body due to the application of this external force, and so it implies that the acceleration of this block will be equal to F minus mu mg. divided by m. So in this case, when we apply an external force F, which is applied in this direction, as shown with the help of this arrow, and this force F is applied parallel to this horizontal surface. The block moves in this direction with an acceleration a. The coefficient of kinetic friction between this block and the surface is mu. So since friction opposes the relative motion, therefore the force of friction will be acting in the backward direction, and the net force which will be acting on this block will be equal to F minus Fs, where Fs is the frictional force. This is also the limiting friction, that is, this is the maximum value of the frictional force which which will be generated when this block moves in this direction. So the acceleration, so the net force is equal to F minus Fs, and since the force is equal to mass into acceleration, and A is the acceleration produced in this body, so m into A is equal to F minus mu mg because n is equal to m into g, so Fs is equal to mu mg. So the acceleration produced in this body will be equal to F minus mu mg divided by m. So this is the first case in which the force is applied on a block resting on a horizontal surface. Now I will be taking another case in which the block is inclined. The block is placed on an inclined surface. Let us say this is a inclined surface. So in this case, the weight of this body, let us say the mass of the block is m, and the coefficient of kinetic friction, mu, is the coefficient of kinetic friction. Kinetic friction between this block and this inclined surface. The angle of inclination of this inclined surface is theta, and so the weight of this block will be acting vertically downward. Now the normal reaction always acts perpendicular to the surface, so the normal reaction will be acting in this direction. This weight can be resolved into two components. One component will be acting parallel to this inclined surface in this direction, and the other component will be perpendicular to this inclined surface. Now this component will be equal to mg cos theta, because this angle is theta. This angle is theta. This is the angle of inclination of this inclined plane, and this component which is acting in the downward direction along this inclined plane will be equal to mg sin theta. Now let us consider that I am applying a force F here. Force F is applied. This is an external force which I have applied, and this external force is applied. The direction of this external force is parallel to this inclined surface, and this is applied in this direction, and because of the application of this external force, the acceleration produced in this block is, say, A. That is, the block starts moving in the upward direction. So the block will start moving in the upward direction only when the magnitude of the external force F is greater than the sum of the forces which are acting in the downward direction. So the sum of the forces which are acting in the downward direction is equal to mg sin theta plus, since the block is moving in this upward direction, the force of friction or the frictional force will be acting in this direction. So this force of friction F, let us say Fs, this will be equal to mu into n. So plus n, this Fs. So this block will start moving in the upward direction only when the magnitude of the external force is more than the sum of the forces which are acting in the downward direction. So the forces which are acting in the downward direction, forces acting in the downward direction is equal to mg sin theta plus the force of friction. This force of friction is equal to mu n. This mu n is also the limiting friction. The limiting friction means this is the maximum value of the frictional force which will be generated due to the motion of this object in the upward direction. So this is equal to mu, and n is equal to what? N will be equal to mg cos theta. So it will be mu mg cos theta. So when the applied force F is more than the sum of the forces which that is when the applied force is more than the forces which are acting in the downward direction, which is equal to mg sin theta plus mu mg cos theta, then this body will start moving in the upward direction. So the net force on the block if it is moving in the upward direction will be equal to F. F is the external force minus the sum of the forces which are acting in the downward direction, which is equal to mg sin theta plus mu mg cos theta. So this is the net force which is acting on this block when it is moving in the upward direction. So now if the acceleration of this block is a, then we can say that m into a. M into a is the force, and this will be equal to minus mg sin theta minus mu mg cos theta. This is the net force which is acting on this block when it is moving in the upward direction, and this will be equal to m into a. So what we can say that it implies that a, that is acceleration of the block, will be equal to F minus mg sin theta minus mu mg cos theta divided by m. So this is the acceleration of this block when it is moving up the inclined plane. That is, a will be equal to F minus mg sin theta minus mu mg cos theta divided by m. So in this way we find the acceleration of an object which is moving up an inclined plane, and when the coefficient of the kinetic friction between the block and this inclined plane is mu. So in the next session I will be taking up another case in which the block will be moving downward, and in this case the block is moving upward. So in the next session, that is session number 8, I will be taking another case in which the block moves downward even if the force is applied in the upward direction. So thank you very much for joining the session, and I hope you have understood the concept behind finding the acceleration of the block which is moving in the upward direction on this inclined plane. So till the next session, I hope first thing is that I hope you must have understood the concept behind finding the formula for this acceleration, and The most important here thing which you have to remember is that the block will move in the upward direction only when the net force acting on this block in the upward direction is more than the forces which are acting in the downward direction. So thank you very much again, and have a nice day. Bye.